Hello everyone, welcome to my channel. Please like and subscribe. In this video, we are required to use three-moment equation to determine the moment at joint B and C, and to draw bending moment diagram and shear force diagram of this beam system. And finally, to find the support reactions at point A, B, and C, which are RA, RB, and RC. In order to use three-moment equation, we are supposed to consider that the beam system is a continuous span. Now, the first procedure is to release the moment at joints, which is joint B and joint C. Joint B is ridge joints and joint C is fixed joints. Now, we release the moment at joint B, which will be equal to x1, and release the moment at joint C, it will be equal to x2. Since the beam system is fixed, we introduce a marginal span like this one. We introduce a marginal span with zero distance. Let's say this is span 1, which is equal to L1, span 2, which is equal to L2, span 3, L3, which is equal to 0 meter. Zero distance with zero moment. This is imaginary span with zero moment. After introducing this imaginary span, and we have introduced hinge joints at joint B and C, now the next step is to draw bending moment diagram due to this applied load. So it's bending moment diagram due to applied load. Draw bending moment diagram due to applied load. Due to applied load. Its bending moment diagram, it will be in this way. This is point A, point B, point C. This is point D. Point D. Now, its bending moment diagram due to point load, it will be in this way. For member AB, its bending moment diagram will be in this way. This is A, B. For member BC, its bending moment diagram due to uniform distributed load, its bending moment diagram it will be in this way. This is maximum bending moment diagrams. Since it's downwards, it will be a negative, negative. So this is A, B, B, C, D. For span CD, I have zero distance and zero moment. So this is zero moment. Now, how to obtain this maximum bending moment for member AB? To obtain this maximum bending moment, it will be equal to FL over 4. F for this case for member AB is equal to 20 times L, which is equal to 4 over 4. It will be equal to 20 kilonewton. For member BC, it will be equal to QL square over 8, which is equal to Q 20 times L square, 4 square over 8. It will be equal to 20 times 4 square over 8. It will be equal to 40 kilonewton meter. Kilonewton meter. This is 20. This is 40. After obtaining this maximum bending moment, the next step is to apply three-moment equation. To apply three-moment equation to determine this unknown moment x1 and x2. Now apply three-moment equation. Apply three-moment equation. Apply three-moment equations. For two unknown, it is given this formula. This is area 1 centroid 1 over EI1 L1 plus area 2 centroid 2 over EI2 L2. Here area 2 centroid 2 over EI2 L2 plus area 3 centroid 3 over EI 3 L3. It will be equal to 2 L1 over EI1 plus L2 over EI2, here L2 over EI2, L2 over EI2, 2 L2 over EI2 plus L3 over EI3 times this unknown moment or this moment times x1, x2, this one. This area 1 is for member, area for bending moment diagram AB. This area 1. Area 2 is area for bending moment diagram for member BC. Similarly for centroid. Centroid 1 is for member AB and centroid 2 is for member BC. Now, how to obtain this area and centroid? EI is stiffness of the beam system. EI1 is stiffness for member AB, which is equal to 2 EI. For member BC, its stiffness is equal to 1, which is EI. Now, how to obtain this area 1 and its centroid? For member AB, since it is triangle, this one, since it is triangle for member AB, since it's triangle, area 1 it will be equal to a half times base times h. A half times base for this member AB, for member AB, base is equal to 4 times h. H is this one, which is equal to negative 20. It will be equal to negative 40 meters square. Now, to obtain centroid of this member AB, for member AB, to obtain centroids, which is centroid 1, it will be for triangle. To obtain centroid of triangle, it is given by area xi over total area. Now, to obtain this centroid, it will be obtained in this way. This is plane axis, this is y-axis, x-axis, this is triangle. Now, this is origin of this plane. This is a center, and this is center of gravity of this triangle. Now, to obtain this, it will be here 2 over 3 times base, 1 over 3 times base. Even for this triangle is 1 over 3 base, 2 over 3 times base. Now, to obtain area 1, since area of this triangle is similar to area of this triangle because base and height are similar. So area 1 will be equal to area 2, which is equal to a half times base times h. Now it will be a half. Now it will be a half times base for this from this to this point, from point A to B is 4 meters. Now from this point to this point is 2, so base 2 times h. H is this one is 20. So it will be equal to area, it will be equal to 20. Now to obtain x1, it will be equal to x1. X1 is distance from the origin to first triangle. This is x1. X2 from the origin to the center of gravity of the second triangle. This is x2. Now x1 will be equal to 2 over 3 times base. It will be equal to 2 over 3 times base, which is base for this triangle is 2. Now it will be equal to 4 divided by 3, it will be equal to 1.33 for x2 to obtain distance from this point to the center of gravity of second triangle. It will be equal to distance from the origin to this triangle, which is equal to 2 plus from this distance to the center. It will be equal to 2 plus 1 over 3 times base. It will be equal to 2 plus 1 over 3 times base, which is equal to 2. It will be equal to 2.67. Now to obtain centroid 1, it will be equal to area 1. Area 1, which is equal to 20 times 1.33 plus area 2, which is equal to 20 times its distance, which is equal to 2.67 over total area. Total area is this one, is 40, or 20 plus 20 is equal to 40, so it will be equal to 40. This distance now, 20 times 1.33 plus 20.2.67 divided by 40. It will be equal to 2 meters. This is the centroid distance of this triangle or for member AB. Okay, to obtain centroid for member BC, to obtain this centroid 2, it will be equal to, we take the distance from member BC divided by 2, means that BC divided by 2, which is equal to L over 2. It will be equal to, this is L2, which is 4 divided by 2, it will be equal to 2 meters. It will be equal to 2 meters. To obtain area for this bending moment diagram for member BC, area is obtained by taking 2 over 3 base times h is 2 over 3 times base. Base for member BC, distance from this point to this point is 4, so it is 4 times h. H is negative 40. It will be equal to 80 divided by 3 times 40. It will be equal to negative 0.67. This is area 2. Now, since 3-moment equation is given in this formula, how to obtain this product of area 1 times centroid 1 over I1 L1. Now let's find this product. Area 1 times centroid 1 over I1 L1. It will be equal to, area 1 is negative 40. This one negative 40 times x1, this one 2 meters over EI1. EI1 is stiffness for member AB, which is equal to 2 times L1. L1 is 4 meters. It's 4 meters. It will be equal to negative 10. Now, for area 2 times centroid 2 over EI2 L2, it will be equal to area 2 is negative 106.67 times centroid 2, which is equal to 2 meters over EI2. EI2 is the stiffness for member BC, which is equal to 1 times L2, which is equal to 4. It will be equal to 2 times 0.67 divided by it will be equal to negative 53.34. Now, after obtaining this product, the next step is to substitute into this 3-moment equation. three-moment equation. Three-moment equation is -6. The product of area 1 times centroid 1 over EI1 L1 is this one. So it will be -10 plus this product area 2 times centroid 2, this one, which is equal to 53.34. Also, the product of area 2 centroid 2, this one, it will be -53.34 plus area 3 times centroid 3. Centroid 3 and L3 for member CD is equal to 0 and its moment is 0. So here is 0 plus 0. It will be equal to 2. It will be equal to 2 L1 over EI1. L1 is this one. L1 is this one. L1 is 4. L1 is 4 divided by EI1. 4 divided EI1 is 2, this one. Stiffness for member AB is 2 plus L2. L2 is 4 divided by EI2, which is 1. 4 divided by 1. Here is L2. L2 divided by EI1, which is 4 divided by 1. Here L2, it will be equal to 4 divided by 2. L2, which is 4 divided by plus 0. L3 divided by EI3 times x1, x2. This is a known or released moment at joint B and joint C. So this it will be equal to negative and negative, it will get positive. So this will be this one plus this one, it will be 63.34. Here it will be 53.34. It will be equal to this one 12. It will be 12 here 4. 8 times x1, x2. Now to obtain these two unknown moments, now use equation of two unknown moments. 12, 4, 6 times 63.34, it will be equal to 4, 8, 6 times 43.34. It will be equal to x1, which is equal to x1, this one, x1, which is equal to moment at point B. It will be equal to 22 kilonewton meter. X2, which is equal to moment at C. X2, this one, it will be equal to 29 kilonewton meter. Now, since we have obtained this released moment, now the next step is to draw final bending moment diagram. Final bending moment diagram. This final bending moment diagram comprises or contains the moment due to point load, this moment, and this moment due to released moment. Now, final bending moment, it will be in this way. This is point A, point B, point C. This is point D. Now, bending moment diagram for member AB due to distributed load was in this way. This is maximum bending moment diagram for member BC was in this way. This is maximum bending moment diagram. Here was 20, 40. Now, this is point A, point B, point C, point D. We have obtained moment at point B is 22 moment at point C is 29. So its bending moment diagram, it will be in this way. Here, bending moment diagram for member B, for point B. So this is point A, B, C. Here, moment at B is 22. Moment at C is 29. This is final bending moment diagram. This is positive, positive. This is final bending moment diagram. Here, this is zero moment. Zero bending moment, zero moment. Now, to obtain shear force diagram, shear force is given by this formula. VI is given by VI is equal to negative Fn 1 minus Lk over L plus Mi minus Mj over L. Vj is equal to summation of Fn 1 minus Lk over L plus Mj minus Mi over L. Now, Fn is point load. Like for member AB, this is Fn point load, and for member BC, Fn is 20 times point load, which act is for member BC. It will be 20 times 4, which is equal to 80. Now, VAB. LK is distance from the center, from where point load acts to the ridge joint. Now, it will be equal to negative Fn for member AB is 20 times 1 times LK, distance from this point to this point, which is equal to 2 over total distance. L is total distance. L is total distance of the member. Like for member AB is 4. Plus My. My for this bending moment diagram, My is from this point to this point. My is this one, which is 0 minus Mj. For member B, Mj is this one, minus 22 over 4. It will be equal to negative 22 divided by 4 plus 20 times 0.5. It will be equal to negative 4.5 kilonewton. Now, for member BA, it will be equal to Fn, which is 20 times 1 minus 2 over 4 plus Mj is this one, 22 minus My, which is equal to 0. 22 minus 0 over 4. It will be equal to 22 divided by 4 plus 10. It will be equal to 15.5 kilonewton. Now for member VBC, it will be equal to negative summation Fn. Fn for this case point load is 20 times 4. It will be equal to negative times 1 minus 2 over plus My for this case, for member B, My is 22 minus Mj. Mj is this one, which is equal to 29 over 4. It will be equal to 22 minus 29 divided by 4 plus times 0.5. It will be equal to negative 8.25 kilonewton. Now for shear force for CB, it will be equal to 1 minus 2 over 4 plus Mj. Remember, Mj is 29 minus My 22 over 4. It will be equal to 7 divided by 4 plus it will be equal to 41.75 kilonewton. These are shear forces of this beam system. Now, how to draw shear force diagram. Shear force diagram. Shear force diagram of the beam system. This is point A, point B, point C. Shear force diagram for AB, since it's point load, it will be in this way, negative 4.5. For VBA, positive, it will be in this way. This is shear force diagram since member AB have point load. So this is positive 15.5. Now for BC, negative, this way. Bending shear force due to uniform distributed load, it will be in this way. This point A, point B, point C. This is negative, which is equal to 38.25. This is 41.75. Now this is positive. And now this is shear force diagram. Now, the final step is to find the support reactions. Support reactions for point A. How to obtain Ri? Ri is obtained by taking VA 0 minus VAB minus VAB. It will be equal to VA0, it will be equal to 0 minus negative VAB is equal to negative 4.5. It will be equal to positive 4.5 kilonewton. To obtain RB, it will be equal to VBA minus VBC. It will be equal to VBA is this one, 15.5 minus negative 0.25. It will be equal to plus 38.25. It will be equal to 53.75 kilonewton. To obtain RC, it will be equal to RC. To obtain RC, it will be equal to VCB minus VCD. VCB is this one, 41.75 minus 0. It will be equal to 41.75 kilonewton. Also, this is a support reaction for this beam system. Thank you for watching this video. Please like and subscribe for more civil engineering tips.